Hello everyone. I hope all of you might have definitely played Carrom Board. So have you seen how the coins collide with each other, how they bounce off the edges, and how they collide with each other, one coin getting displaced by other coin? Okay, so do you understand what I'm talking about? I am talking about collisions. There could be many kind of collisions when we write a game. According to the game, we may want to put up the collisions. In Game Lab, there are 4 types of collision available, and today in this session, we will understand these 4 types of collision in detail. Let me show you a sample of it. How does it works in Game Lab? Do you see these 4 kind of collisions? I am running it again. Observe it again. Okay, don't worry. Let's understand about each of them in detail now. There are 4 types of collision available in Game Lab: displace, collide, bounce, and bounce off. So what are these different kind of collisions and how do they work? Let's talk about displace first. So in displace, assume if you have 2 sprites, source and the target sprite. So whenever we talk about collision, of course, there has to be 2 objects. One is the source and another one is target object or the sprite. You can, say them sprite or object. It's okay. So before collision, let's assume there is a target which has a velocity x0, velocity y also 0. So basically it is stand still. It is not moving in any direction. While there is another object or another sprite which is moving in x direction with +2 velocity. Okay, so this is my source sprite and this is my target sprite. Source sprite which is moving in this direction, velocity 2, and my target sprite is stand still. It is not moving anywhere. The collision happens between source and the target. And what will happen if it is a displace type of collision? In displace type of collision, the target also takes a velocity of source and it moves along with the source in the same direction. Okay, so the target takes the velocity of the source and it moves along with the source in the same direction. So if I want to show everything in one picture, this is how it will look like. Before collision, source was moving in velocity x direction, positive x direction, to velocity 2, while my target was still. Okay, when the collision happens, after collision, source and target both occupies the same velocity of 2. In this project, I have already created these couple of sprites. So very simple sprites, just a square with the labeling so that we understand which kind of collision we are going to try. For displace, I have put a D. For displace target, I have put DT so that on my screen, I can understand which type of collision I am talking about, which object is this. Okay, so this displace target we will use now. So quickly, let's put up the sprites together, these 2 sprites. I'm giving it name as displace source. Okay, let me position it somewhere 53, 57. Another is going to be displace target. I am creating this sprite at maybe 350 and 63, 57. Okay, let's give them animation. Displace, okay. And for other one, that is displace target. Set displace target animation and then draw sprites. Let's see how does they come up on the screen. Okay, so they come up nice. There is one displace, one sprite source, and this is going to be my target sprite. So what I will do in this case? First experiment. What will be my first experiment? So let's, put this up as number one experiment. What I will do in this number one experiment, I will keep the velocity of target as 0. So it means displace target dot set velocity dot velocity x is equals to 0. Okay, and I will give this source a positive velocity in x direction, so that when it comes like this here, it collides with my target. Okay, if I give it a positive velocity, what will happen? It will go in this direction towards right. So to this, I am going to give a positive velocity, maybe a velocity of 3. Let me put the background. Let me paint the background. This is what I should say. Okay. So what do you see? Because we have not put any type of collision, this source simply pass on by the target. Target is still at one place. But if I want them to move along or them to give a displacement collision, first I will have to give that collision. So first thing, let me move this to maybe at 280 position. This seems to be two-way towards the right hand side. Yeah. Now we will put up this command. What is the command? If we want one sprite should displace other sprite. So the command is going to be my displace source dot displace. Displace is the command, and inside the target, I am going to give my target sprite. What is my target sprite in this case? My target sprite is displace target. Okay, so let's see what happens. After this, do you notice that my displaced target is also moving along with the source? It has actually taken the velocity of source as soon as both of them touches together. So that was about displace. The same thing. Okay, my target takes the velocity of my source. What is the next type of collision? The next type of collision is collide. What happens in collide type of collision? So let's understand it with this example. Say we have a source and a target. Source is moving in with velocity x towards right hand side, and my target is moving with velocity -2. Velocity x of -2 in left hand side direction, and both of them collide. Both of them collide at some point. When both of them collide at some point, what happens? Here, you should understand that it is actually the opposite of displacement collision. Because in displacement, what was happening? The target was taking the velocity of source. But here, my source is going to take the velocity of target. My source is going to take the velocity of target. Okay. So how does this overall picture looks like? Is something like this. Okay, I have a source, I have a target. Source is moving with a velocity x of 2. Target is moving with a velocity x of -2. So basically, both of them are moving in opposite direction. Then only the collision will happen. There happens a collision, and after collision, the target and the source have the same velocity, and source also takes the velocity of target. So let's do this experiment. Okay, so let's go to animation. I have already put up these two sprites, C and CT. C is for collide source and CT is for collide target. Let's write some code quickly. Quickly put up two sprites. One for collide source and another for collide target. So the position could be somewhere, I will say 50, 150. Let me make this also 50 and this also 60 and this also 60. Okay, so this let me take 50 and 150 and another one collide target. That could be 280, 150. Let's give them animations. Light, and the other one will be target. Okay, let's run it. Yes, so we have here we have this collide as source and collide target as my target. What I'm going to do, as of now, I have not given them any velocity. I have never, I have also not put up any code so that, they both of them collide. So I'm just going to give maybe this CT target as a velocity of 0, velocity x. Velocity x, I'm giving this as 0, while it comes with some velocity. So to collide source, I am going to give the velocity x as, say, for example, 2. We can give any. Let me give 3 also. Okay. So reset and run it. Okay. So it, passes on because I have just given them the velocity. I have still not written the code to collide. So the way we had written here, the code of displacement, let's write the code of collide. So collide source, this sprite is colliding. The command is collide with my collide source. Okay, like this. It is colliding with my collide source. Now let's run it and see. Sorry, there is a mistake. Not with collide source. It collides with collide target. I have actually kept the source and target both same. So that's why the mistake. So yeah. So did you notice what happened in this case? Both these sprite stops. Why both these sprite stops? Because my velocity x of collide target was 0 here, right? Let's do another experiment. Let's put this as velocity -2. Okay, we can't keep it +2 because if both are going in same direction, the two sprites will never collide. They will never touch each other. So I will reset, run it again. Okay. So now what happens? Did you notice? My source is also moving along with target, which is just opposite of display. The next type of collision that we will talk about is bounce. Okay. So what happens in bounce? Say for example, if you have source and target, source is moving in right direction with velocity x2 and target is moving in left direction with velocity -2. The collision happens in both of them, and after collision, both the velocities are interchanged. So what does it mean that both the velocities are interchanged? So my source takes the velocity of target and my target takes the velocity of source. Okay, so if you want to see it in one single picture, this is how it will look like. Source has got velocity of velocity x of 2, target has got a velocity x of -2. Both collide, and after collision, both the velocity are interchanged. So basically, if source was going in right direction, it will start going in left direction, and the target was, if it was going in left direction, it will start going in right direction, and the velocities will exactly interchange. I mean, these numbers will also interchange. So let's see it now. Let's quickly put up the sprites. So we have this bounce underscore as a source and bounce underscore t as target sprites. Okay, let's give them animation. Bounce and bounce target, which also I have already created in the same fashion. bounce target. Okay. Fine. Let's see where they are created. Yes. Okay. These two are created. Bounce and bounce target. Let's give them some velocities. So I will give both of them a velocity. Maybe this could be 2. And for another one, we will give -2. Okay, so let's run it. Okay, so both are going in opposite directions. We have still not written the code to bounce. So let's write the code to bounce it. We will say bounce underscore s. This sprite should bounce with target sprite. So within the bracket, we will give the name of the target sprite. Let's reset and run it. Okay, so did you see after the collision, both the sprite started going into the other direction, into the opposite directions. And the last one which we are going to see is bounce off. So what is this bounce off? In bounce off also, let's assume that we have a source and a target. Source is going in the right direction with velocity x2 and the target is going in the left direction with velocity x of -3. Both of them collide. So what will happen after collision? After collision, source starts going in the same direction as of target, but its speed or the quantum or the speed is multiplied. So initially, if you see, its velocity was only -2, but now it has been multiplied and it becomes -8. If let's see it in a complete one picture, how does it look like? So source and target are going in opposite direction. They collide. Source also takes the direction of target and its velocity is multiplied. Velocity of target remains same while the velocity of source is multiplied. Okay, don't get confused. But this bounce off is the most used type of collision when we do game programming. Bounce off is the most used type of collision. And in this, what happens generally, my target's velocity is 0. Say, for example, if we want to create a ping pong game, so my target's velocity could be 0 while my source is jumping up and down. Okay, so my target will still be 0 because my target's velocity is not changing. What is changing is only my source's velocity. While in bounce, both the velocities are interchanged. Okay, if they're coming like this, they start going in the opposite direction. Exactly opposite direction, they will start going. While in bounce off, the target still keep on going in the same direction and source will move back with a higher speed. Okay, let's see it. Need to create the sprites first. Bounce off source and bounce off target. Let's see if they are at the right position where I want them to be. Okay, so this has to be a little down. Let's give them animations first. Bounce off it has to be, sorry. Dot set animation, bounce off target. Okay. Okay. So this has to be 250, of course. Let me correct it. And okay, so this is my bounce off source and this is my bounce off target. Let's give them some velocities now. Bounce off source, the velocity x, say for example 2. And okay, let's do not give any velocity to the target. Let's keep it as it is. Okay, so you will notice that the velocity of target is not changed. Oh, we need to first give them the bounce of character. So let's give them the bounce of character first. So source, and whenever we are writing the any type of collision, it is like, source dot the command, and within the bracket will come the name of the target. Bounce of the let's reset, run it and see it. Notice the bounce off. Okay, so do you see it is still? It still means it is with its same original velocity. It is not changing its velocity. While my source, when it collides with the target, it bounces in the reverse direction and its velocity may also increase. Here, because it is colliding with the object which do not have any velocity, its velocity is same. But if it collides with the object which has got its velocity will increase. So let me give some velocity to bounce off target as well and show it to you. -3. Okay, let me run and show it to you. So do you see bounce off sources, going back with so much of speed? Yes. So that was bounce off. This is a complete view of all the 4 types of collision. So let's revise them quickly. Displace, source and target. In displace, after the collision, target takes the velocity of source. In collide, after collision, source takes the velocity of target. In bounce, both the velocities are interchanged after collision, and in bounce off, there is no change in target's velocity, while source velocity is reversed and multiplied. Basically, it increases based upon the velocity of target. Bounce off is the most used type of collision when we do game programming. So in next session, we will create an interesting game using this bounce off. Stay tuned.